Okay, so what we're trying to do here is we're trying to take -1 plus I, or any complex number, to an arbitrary exponent. Let's say to the 6th power. I'm going to choose this one because I know the answer is 8 pi. Or not 8 pi, it's 8i. Excuse me. 8i. Now this is tedious to do by hand. You have to basically do the binomial expansion, which means you're going to have to do -1 plus I times -1 plus I times -1 plus I. And okay, by the time you multiply this to every term of every term of every term of every term, let's not do it that way. Let's not do it that way at all. So, what we're going to do to find -1 plus I to the 6th power is we're going to convert this to polar. This complex number works really well in polar. So let's get ourselves a coordinate plane. Remember, when we're working with complex numbers, there's a real axis that's sort of like the equivalent to the x-axis. And there's an imaginary axis that's sort of like the equivalent to the y-axis. So our -1 plus I will actually go -1 on the real, so over here, -1, and plus I, so that's +1 on the imaginary. It's going to come up about like this, which is at a 45-degree angle from the imaginary axis. Which means if you convert to a angle, that's about 3 pi over 4. So recall, when we're going to polar, we're going to have our modulus times our e to the I theta, where theta is our angle, modulus being basically the length of this vector here, and theta being the angle of this vector. So we've got our angle part, it's e to the I, that's just part of the definition, times 3 pi over 4. Now for our modulus, let's switch to red here. You are going to take the square root of the real part squared plus the imaginary part squared. That's the imaginary part without the I. So in this particular case, we're going to take the square root of -1 squared plus, there's a 1 in front of this I, 1 squared, which square root of 1 plus 1 is √2. Okay, now that means we've got a √2 times e to the I, 3 pi over 4 is our -1 plus I. And let's not forget, we want to take this whole thing to the 6th power, which is much easier now because we don't have a binomial. So square root of 2 to the 6th is 2 to the 6/2, or 2 to the 3rd, also known as 8. So it's going to be 8 times e to the I, 6 times 3/4 pi, okay? 6 times 3/4 is 3 times 3/2 is 9/2. So our final thing is going to be 8 e to the I times 9/2 pi. And because 9/2 is basically, you go around twice and then you come up another pi over 2, that's equivalent to saying 8e to the I pi over 2. E to the I pi over 2 is going to be, I'm going to switch to this color. E to the I pi over 2 is, on this, it's completely imaginary. So that's back to saying it's 8e to the I pi over 2, that's 8i. If you want to check it, you can use Euler's identity, or the de Moivre expression, however you want to call it, that basically says e to the I theta is equal to sine of theta plus I cos theta? Well, sine of pi over 2 is 1. Or, excuse me, it's been a few days since I've done this. Cos theta plus I sine theta. Okay. The cosine's the real part. Anyway. So cos of pi over 2 is 0 plus I times sine of pi over 2 is 1. So e to the I pi over 2 is I. So your final answer is 8i. 8i, which we said it was in the first place.